Assalamualaikum and have a good day today. Okay, we continue, yeah. Module 11, network design, okay. Okay, title is network design. Objective of this module, explain the characteristic of scalable network architecture, yeah. All right, so topic in here, we have hierarchical networks, scalable, we have switch hardware and router hardware. Hierarchical networks explain how data, voice, and video are converged, yeah, in a switch network. For scalable, explain consideration for designing a scalable network. For switch hardware, explain how switch hardware features support network requirement. And for the router hardware, describe the type of routers available for small to medium size of business. Yeah. All right. So hierarchical networks. Yeah. So video will demonstrate the 3-layer model in network design. Okay, here is the video.
Let's take a look at this sample network topology and the networking devices, intermediary devices, and end devices that make it up. First of all, this network has been divided into a 3-layer hierarchical network design. We have the network access layer here, the distribution layer here, and the core layer here. At the network access layer, we have 2 workgroup switches. These are layer 2 switches capable of supporting VLANs, quality of service QoS, and power over Ethernet. We can see here how power over Ethernet is powering this access point, and power over Ethernet is also powering this IP phone. The IP phone also needs quality of service in order to maintain the quality of a voice conversation across the network. There are multiple VLANs that it supports. We have a guest network here with this blue VLAN. We have user VLANs here, the yellow VLAN and the green VLAN. Notice that this user has also attached a hub to the network so we can support extra devices. This type of activity could be considered a violation of network policy, and port security could be used to shut down this hub and these extra devices. At the distribution layer, we have 2 multi-layer switches. These are layer 3 switches that are not only capable of switching, but can also provide routing, including static routes and dynamic routing. These switches can also apply network policies through access lists. At the core layer, we have a multi-layer switch whose role it is to forward packets as fast as possible to the Edge 1 router. The Edge 1 router is capable of network address translation as well as being an edge firewall to the internet. In this network, the Edge 1 router connects to a cable modem, which then connects to the internet service provider and then out to the internet.
Okay. So that's the video. Okay, the need to scale the network. Organizations increasingly rely on their network infrastructure to provide mission-critical services. Organization require network that can scale and support. Converge, network traffics, critical applications. We have a diverse business needs and also centralized administrative control. Campus network design includes small network that use a single LAN switch up to very large network with thousands of connections. So borderless switch network. The Cisco borderless network is a network architecture that can connect anyone, anywhere, anytime, on any device, securely, reliably, and also seamlessly. It also provides the framework to unify wired and wireless access built on hierarchical infrastructure of hardware that is scalable and resilient. Modular switch network are hierarchical, modular, resilient, and also flexible. Yeah. Hierarchy in the borderless. Yeah. Switch network. Hierarchical networks use a tier design of access, distribution, and core layers, with each layer performing a well-defined role in the campus network. There are two time-tested and proven hierarchical design framework for campus networks. Okay. So you can see these two. Yeah. This is 2-layer and this is a 3-layer. All right. Okay, access distribution core layer function. Okay, access layer function. The access layer provide network access to the user. The access layer switches connect to distribution layer switches. And also as a distribution layer implements routing, quality of service, and also security. It aggregates large-scale wiring closed network and limits a layer to broadcast domain. Distribution layer switches connect to access layer and core layer switches. And core layer function is the network backbone and connect several layers of the network. And also the core layer provide fault isolation and high-speed backbone connectivity. 3-tier and 2-tier example. 3-tier campus network used by organization requiring access, distribution, and core layers. The recommendation is to build an extended star physical network topology from a centralized building location to all other buildings on the same campus. 2-tier. Use when separate distribution, and core layers is not required. So use for a small campus or campus sites consisting of a single building, also known as the collapsed core network design. Role of switch network. Network have fundamentally changed from a flat network of hub to switch LANs, to switch LAN in a hierarchical network. A switch LAN actually allows additional flexible traffic management, quality of service, and security. And switch LAN also support wireless networking and other technologies such as IP telephone and mobility services. Scalable networks. Design for scalability. Scalability is the term of a network that can grow without loss, losing availability and reliability. Network designer must develop strategies to enable the network to be available and to scale effectively and easily. This is accomplished using redundancy, multiple link, scalable routing protocol, and finally wireless connectivity. Plan for redundancy. Redundancy can prevent disruption of network services by minimizing the possibility of single point of failure by installing duplicate equipment. Provide failover services for critical devices. Redundant path offer alternate physical path for data to traverse the network supporting high availability. However, redundant path in an internet network may cause logical layer 2 loops. Therefore, spanning tree protocol is required. Is the one. Reduce failure domain size. A well-designed network controls, a well-designed network controls traffic and limit the size of failure domain. In example, the area of network that is impacted when the network experiences problems. In the hierarchical design model, failure domains are terminated at the distribution layer. So every router functions as a gateway for a limited number of access layer users. Router or multi-layer switches are usually deployed in pairs, in a configuration referred to as a building or departmental or switch block. Each switch block act independently of the others. As a result, the failure of single device does not cause the network to go down. Increase bandwidth. Link aggregation. Okay, this one all under scalable network. For example, ether channel allows an administrator to increase the amount of bandwidth between devices by creating one logical link made up of several physical links. Ether channel combine existing switch port into one logical link using a port channel interface. Most configuration tasks are done on the port channel interface instead of each individual port to ensure configuration consistency on the link. Ether channel can load balance between links. Expand the access layer. An increasingly popular option for extending access layer connectivity is through wireless. Wireless LAN provide increased flexibility, reduce costs, and the ability to grow and adapt to change network and business requirements. To communicate wirelessly, and devices required a wireless NIC to connect to a wireless router for a wireless access point. Consideration when implementing a wireless network include type of wireless devices connecting to the wireless LAN, wireless coverage requirement, interference consideration, and also security considerations. Tune routing protocol. Advanced routing protocol, such as Open Shortest Path First or OSPF, are used in a large network. OSPF is a link state routing protocol that uses areas to support hierarchical networks. OSPF routers establish and maintain neighbor adjacencies with other connected OSPF routers. OSPF routers synchronize their link state database. When a number change occurs, link state update link state updates are sent, informing other OSPF router of the change and establishing a new best path if one is available. Switch hardware. Switch platform. There is a variety of switch platform, form factors, and other features that must be considered before choosing a switch. When designing a network, it is important to select the proper hardware to meet current network requirement, as well as to allow for network growth. Within an enterprise network, both switches and also routers play a critical role in network communication. Okay, campus LAN switches such as Cisco 3850 series shown here, this one, support high concentration of user connection with speed and security appropriate for the enterprise network. Cisco Meraki Cloud Managed access switches okay, Cisco Meraki Cloud Managed Access Switches, right? Enable virtual staking of switches. They monitor and configure thousands of switch ports over the internet without the intervention of on-site IT staff. The Cisco Nexus platform promotes infrastructure, scalability, operational continuity, and transport flexibility in the data center. Service provider Ethernet access switches at the switches service provider Ethernet access switches feature application intelligence, unified services, virtualization, integrated security, and simplified management. Cisco Nexus virtual networking switch platforms provide secure multi-tenant services by adding virtualization intelligent technology to the data center network. When switch form factor, when selecting switches, network administrator must determine the switch form factors. This includes fixed configuration, modular configuration, stackable, and non-stackable. Features and options on fixed configuration switches are limited to those that originally come with the switch. The cases, the cases on modular switches accept field replaceable line card. Special cables are used to connect stackable switches that allow them to effectively operate as one large switch. The thickness of the switch, which is expressed the number of rack unit. It also important for switches that are mounted in a rack. For example, the fixed configuration switches shown in the figure here are all one rack unit, 1U or 1.75 inches, similar to 44.45 millimeters in height. The port density. The port density of switch refers to the number of ports available on a single switch. Fixed configuration switches support a variety of port density configuration. The Cisco Catalyst 3580 come in 12, 24, 48 port configuration. For the modular switches, can support very high port densities through the addition of multiple switch port line card. The modular Catalyst 9400 switch support 384 switch port interfaces. Forwarding rate. Forwarding rate defines the processing capabilities of switch by rating how much data the switch can process per second. Switch product lines are classified by forwarding rates. Entry-level switches have lower forwarding rate than enterprise-level switches. If switch forwarding rate is too low, it cannot accommodate full wire communication across all of its switch ports. Wired speed is the data rate that each Ethernet port on the switch is capable of attaining. Data rate can be 100 megabit per second, 1 gig, 10 gig, and 100 gig bit per second. Access layer switches typically do not need to operate at full wire speed because they are physically limited by their uplink to the distribution layer. POP or Power over Ethernet. Power over Ethernet or POP allows the switch to deliver power to a device. For example, iPhone, AP, access point, and also camera over the existing Ethernet cable. A network administrator should ensure that PoE features are actually required for a given installation because switches that support PoE are expensive. Multi-layer switch. Multi-layer switches are typically deployed in the core and distribution layers of an organization switch network. They support some routing protocol and forward IP packet at a rate close to that of layer 2 forwarding. Multi-layer switches often support specialized hardware such as application-specific and integrated circuit. ASIC along with dedicated software data structures can streamline the forwarding of IP packet dependent of the CPU. Business consideration for switch selection. Consideration first, a cost. Cost. The cost of a switch will depend on the number and speed of the interfaces and supported features and also expansion capabilities. Port density. Network switcher must support the appropriate number of devices on the network. Power. It is now common to power access point or IP phones and compact switches or user power over Ethernet PoE. In addition to PoE consideration, some cases-based switches support redundant power supply. And then for reliability, the switch should provide continuous access to the network. Port speed, the speed of the network connection is of primary concern to end user. Buffer frame, the ability of the switch to store frame is important in a network where there may be congested port to serve or other areas of the network. Scalability, the number of users on a network typically grow over time. Therefore, the switch should provide the opportunity for growth. Router hardware. Router requirement. Router use the network portion, which is prefix of the destination. IP address, the destination IP address to route packet to the proper destination. They select an alternate path if a link goes down. All hosts on a network specified the IP address of the local router interface as their default gateway. Routers are also serve other beneficial function as follow. First, they provide broadcast containment by limiting broadcast to the local network. They interconnect geographically separate locations. The group user locally by application or department within a company who have command needs or required access to the same resources. They provide enhanced security by filtering unwanted traffic through access control lists. So here is Cisco router. Branch router shown in the figure optimize branch services on a single platform while delivering an optimal applications experience across branch and one infrastructures. Shown are the Cisco Integrated Services Router ISR 4000 series routers. Network edge router shown in the figure enable the network edge to deliver high performance, highly secure, and reliable services that unite campus, data center, and branch network. Some shown are the Cisco Aggregation Services Router 9000 series router. Service provider routers shown in the figure deliver end-to-end scalable solution and subscribe aware services shown are the network convergence system, 6,000 series routers. Yeah. Industrial routers such as the one shown in the figure are designed to provide enterprise class features in rock and harsh environment. Shown are the Cisco 1100 series industrial integrated service routers. Cisco 900 series. This is a small branch office router. It combines WAN, switching, security, and also advanced connectivity option in a compact, fanless for small and medium-sized business. Cisco SR 9000 and 1000 series aggregation services router. This router provide density and resiliency from or with programmability for a scalable network edge. Router form factors. Cisco Network Convergence System 5500 series router. These routers are designed to efficiently scale between large data center and large enterprise network edge and service provider one and aggregation network. Cisco 800 Industrial Integrated Service Router. This router is compact and designed for harsh environment. Okay, that's all. Thank you for watching.